Now we move to the full wave bridge rectifier. So this one's a little more complex, only in that it adds two more diodes. So a full wave bridge rectifier uses four diodes. When the input cycle is positive, as in part A, diode 1 and diode 2 are forward biased and conduct current in the direction shown. A voltage is developed across the load resistor that looks like the positive half of the input cycle. During this time, diode 3 and diode 4 are reverse biased. When the input cycle is negative, as in sketch B, diodes 3 and diodes 4 are forward biased and conduct current in the same direction through the load resistor as during the positive half cycle. During the negative half cycle, diode 1 and 2 are reverse biased. A full wave rectified output voltage then appears across the load resistor as a result of this action. From transformer theory, the secondary voltage is equal to the primary voltage times the turns ratio, as we saw earlier. So in this relationship, V on the secondary is equal to the number of turns N times V of the primary. This equation can be applied because both V secondary and V primary are peak values. Because the input voltage Vn is the same as the primary voltage as long as the fuse is good, the peak secondary voltage can be expressed as Vp secondary, the peak, equal to the number of turns N times V peak N. As you can see in the figure 1635, two diodes are always in series with the load resistor during both the positive and the negative half cycles. Neglecting the barrier potentials of the two diodes, the output voltage is a full wave rectified voltage with a peak value equal to the peak secondary voltages. So V peak out is equal to V peak at the secondary. As for the peak inverse voltage, let's assume that the input is in its positive half cycle when diode 1 and 2 are forward biased, and examine the reverse voltage across diode 3 and 4. In the figure 1636, you can see that diode 3 and 4 have a peak inverse voltage equal to the peak secondary voltage, Vp secondary. Since the peak secondary voltage is equal to the peak output voltage, the peak inverse voltage then is, in this relationship, V peak out. The peak inverse voltage rating of the bridge diodes is half that required for the center tapped configuration for the same output voltage. Let's take a look at this example. Determine the peak output voltage for the bridge rectifier. What minimum peak inverse voltage rating is required for the diode? So we've got 25 volts in on the primary of the transformer. We've got a 1-to-1 ratio for the transformer, and we've got a full wave bridge rectifier. The peak output voltage then is V peak out, which equals V peak on the secondary, which is the number of turns times V peak in. So in this case, we saw we had a 1-to-1 transformer, so 1 times V peak in, 25 volts, gives us 25 volts out. The peak inverse voltage for each diode then is PIV is equal to V peak out, and again 25 volts. So when we come back, we're going to take a look at other applications for power supplies where we use diodes.